Hello everyone, this is Taslima Nasrin. I am an intern at EMERTXE Information Technologies. During our project, I have built a home automation project based on IoT. Today, I am going to give a presentation on the project which is IoT based home automation. So, let's begin. The contents are introduction of learned concepts in which we discuss C programming, IoT, Internet of Things, embedded systems and microcontroller. Later we will look into project overview, objective, design elements, simulation and finally conclusion. The first one, C programming. It is a general purpose language even though it is applied and used effectively in various specific domains. The structure of simple C program is as shown. It includes file header, preprocessor directive, the start of program which is nothing but main function, open and closed braces in which we include comment, statements and program termination. The topics discussed in C are data type, modifier and qualifier, conditionals and loops, operators, arrays and pointers, functions, storage classes and preprocessors. Next topic, IoT, Internet of Things. IoT is nothing but a collective network of connected devices. It is a technology that facilitates communication between devices over the internet. IoT system works through the real-time collection and exchange of data. The applications of IoT are automobile, manufacturing, logistics and transport, and for business. The examples of IoT are wearable health monitors, smart cars, smart buildings, and home automation. Next topic, embedded systems. Embedded system is defined as a combination of computer hardware and software designed for a specific function. They are low cost, low power consuming small computers embedded in other mechanical or electrical devices. Generally, embedded systems comprise a processor, power supply, memory, and communication ports. Here, the picture represents the basic architecture of embedded system. It contains sensor, A to D converter, processor and ASICs, application-specific integrated circuits, D to A converters, actuators and memory. Sensor measures the physical quantity and converts it to an electrical signal which can be read by an observer or by any electronic instrument. A to D converter converts analog signal sent by the sensor into a digital signal. Processor and ASICs processes the data to measure the output and store it to the memory. D to A converter converts the digital data fed by the processor to analog data. And last one, actuator. It compares the output given by the D to A converter to the actual output and stores the approved output. The embedded systems are applied in various areas. They are electronics, medical field, automotive industry, telecommunications, security systems, and robotics. The examples of embedded systems are CAT scanners, implanted heart monitors, electric vehicles, and household appliances. Next, microcontroller. Microcontroller is defined as an integrated circuit used in embedded systems such as cars, coffee makers, and IoT devices. The working principle of a microcontroller is fetch, decode, execute cycle. The CPU fetches an instruction from the program memory, decodes it to determine the required action, and executes the instruction accordingly. This cycle repeats continuously until the program ends or is interrupted. Under the concept of microcontroller, we discussed about ADC and DAC blocks, timers and counters, PWM, processor, memory and IO ports, differences between microprocessor and microcontroller, RAM, ROM, and its types. Next, move on to the next topic, project overview. This project provides an IoT based home automation solution using Arduino Uno board in PicSimLab simulator. Blink IoT mobile application is used to control the devices remotely. We can control the lights, temperature of the room, and inflow and outflow of water in the water tank. The project objectives are to connect the home appliances to the PicSimLab simulator and integrate it with Blink IoT app using Blink Cloud. We can control lights, temperature of home along with the level of water tank using mobile phone. We can also obtain notification about the status of home on the mobile phone. The question now arises is, why home automation? What is the need of it? Here is the answer. Generally, people always don't stay at home. This brings the problem of home appliances not being monitored. The solution for this problem comes out to be home automation. Home automation enables people to control most of the devices remotely, such as volume of water present in the water tank, garden lights, temperature of home. Now let us see what is Arduino. Arduino Uno is a microcontroller board based on the Atmega 328P. It has 14 digital I/O pins, 6 analog I/O pins, a 16 MHz ceramic resonator, a USB connection, a power jack, an ICSP header, and a reset button. It can be programmed using different IDEs, integrated development environment. In this project, we are using Arduino IDE. Arduino IDE supports both C and C++ languages. The below figure represents the Arduino Uno board. Next, PicSimLab. PicSimLab is an open source real-time emulator of development boards with integrated MPLABX AVR-GDB debugger. It supports some PicSim microcontrollers and some SimAVR microcontrollers. It has integration with Arduino IDE for programming the board's microcontrollers. The figure represents the PicSimLab. Next comes Blink IoT app configuration. It is used to create new templates, add devices, to select and add data stream, to create icons, and to include Blink memory, Blink library. Now let us discuss LDR, light dependent resistor. LDR sensor is a light detecting sensor that detects the light that falls upon it. The photoresistor is a light controlled variable resistor. The resistance of a photoresistor decreases with increasing incident light intensity. The LED lights are connected to the LDR via the ADC. The ADC converts the analog input by the LDR into its equivalent digital form, which is then converted later by certain formula from 0 to 255 as upper bound. Based on that, we glow the LED. The beside graph represents how LED is functioning. As the light intensity increases, the resistance decreases. Next comes garden light control. The properties of LDR sensor is applied to accomplish the controlling of garden lights. During the day, the outdoor light is maximum, so the LDR sensor detects the light and the garden light is turned off. Whereas at night, the outdoor light is very low, so the LDR sensor detects the light and the light is turned on. Next comes temperature sensor. The temperature is recorded using LM35 sensor, which reads analog value. The value is converted into binary value and later actual temperature is calculated using the obtained value of the voltage. The sensor does not require any external calibration or trimming to provide accuracies of plus or minus 0.5 degrees C at room temperature and plus or minus 1 degree C over the minus 50 degrees Celsius to 155 degrees Celsius temperature range. The output scale factor of LM35 is 10 millivolts per degree Celsius. For instance, it provides an output voltage of 250 millivolts at 25 degrees Celsius. The figure beside it represents the temperature sensor. Next, let us discuss temperature control system. The figure represents the functioning of temperature control system. The temperature control system consists of a heating resistor, an LM35 temperature sensor, and a cooler. Analog value of temperature is obtained from the temperature sensor LM35 and display it on the CLCD after converting it into digital value using ADC. It controls the temperature of the system by turning on or off the heater and cooler through the Blink IoT mobile application. Next topic, water tank inlet and outlet valve controller. The figure represents the block diagram of water tank inlet and outlet valve control. The function is it reads the volume of the water in the tank through serial communication and display it on the CLCD. The latter controls the volume of the water in the tank by controlling the inlet and outlet valve by sending commands through serial communication and display the volume of water in the tank on the CLCD and also in Blink IoT app. The tank refills itself when the outflow exceeds the threshold of minimum value 2000 liters and it stops filling when the tank is full at 3000 liters. And it also gives the notification to the Blink IoT application. Next, this figure represents the simulation image. Now, I will explain you the code for this home automation project. First of all, we are including all the required header files and libraries into it. Then, we are writing our authentication code, which is of Blink Cloud. Then we are initializing the variables declaring it and we are including the libraries that is required. Then we will mention different functions and their definitions into it. So this cooler weapon function defines it. It gives us the control to control the cooler by clicking it on and off using our mobile apps, and the LCD will display the cooler is on and the cooler is off. Similarly, when it comes to heater V pin, this will take the input and then it will also display when the heater is on. It will show on and then when the heater is off, it will show off on the LED screen. The inlet V pin will display the inlet flow of water tank, so it will again enable the inlet and it will show that the curves on the LED screen whether the flow is on or off, and it will take parameters. It will read the values from the Blink app. Similarly, for output pin, it will again show whether the flow is on or off on the LCD screen, and these methods are called enable output and disable outlet. We can update the temperature reading will be helpful for us to give the values to IoT app. So basically the app will show the display of the temperature as the temperature is moving. Even the water value will be displayed on the mobile app. When it comes to handle temperature, this will check if the temperature is greater than 35 degrees. Then the heater will turn off and then it will print as the heater is turned off, and similarly a notification window will appear on the mobile IoT app where it displays that the heater will be off because the temperature is exceeding 35 degrees Celsius. When it comes to the function of handling the tank, this will mention that if the tank volume is less than 2000 and the inlet valve is closed at that moment, it will turn on the inlet valve and it will show that the flow is on, and the notification will be printed on the mobile app that water level is less than 2000, so the flow will be on. Similarly, if there is the volume of 3000 and if the inlet valve is open at that moment, it will disable the valve. That means the flow will be stopped and it will be mentioned on the LCD that the flow is swapped. Simultaneously, on the notification window of the app, it will be mentioned that water level is full, so flow is stopped in the setup. In the setup, we will always initialize and declare the init methods, and in the loop we will always call the method that is already declared. In ldr.cpp, in this file we are declaring the brightness control method, which means this method will declare that the blinking of LED with the help of LDR in ldr.h. It is the header file where we have declared the macros LDR sensor and we have given it as a value, and we have also defined the methods it may. Here also we have declared all the macros that we are using in the program. Serial tank.cpp will be declaring all the methods into it. In this volume method, it will declare the volume, how much volume is there in the tank and not, and the different methods like enable inlet will show that the inlet valve is enabled or not. Disable inlet and various methods are declared over here. In serial tank.h, that is, it is a file that will mention all the macros in it, and the method names are declared over here. Temperature system.ccp will give us about the method's name, that cooler control, that means it will give digital write cooler dot control, which means that the values will be read by the system when the machine is on and off, and it will be passed and declared in the LCD. Similarly, when it comes to temperature, this will convert the temperature into degrees Celsius. This method will be helpful to convert the temperature into degrees Celsius. It will declare all the methods that is required for the temperature system. Enter temperature.system.h. This is the header file where we are already declaring the method names, and we are declaring all the macros in this way. We will be able to code our system, and once our code is ready, we will compile it and we will upload the compiled code in the Arduino. Once the compilation is done, the hex file is ready. Here the compilation is done and our code does not have any error, so we can upload it on the PixSimLab. Now let's look at the simulation part. So this home automation project consists of blinking of LED with the help of LDR. When we slow down the resistance, the light turns off, and when we increase the resistance, the light will turn on. Remaining part can be controlled by our mobile application. Here I have kept on the Blink app, where we can see the option of cooler. When we click on, the cooler starts to on, and over on the screen we will see the cooler is on. When we click the option off, the cooler will stop and it shows as the cooler turns off. When we click on the heater on, the temperature on the screen will increase, and when it turns above 35 degrees, automatically the heater turns off. Here we get a pop-up message that temperature is above 35 degrees Celsius, turning off the heater. If we again turn it on, it will increase the temperature, but automatically again it will turn it off. And when we turn on the cooler, the temperature decreases. The fan also turns on, and here on the screen we will also get the temperature is decreasing. Similarly, if we turn it off, it turns off. When we go to the second tab, which indicates the water level. We can see it with the help of the serial monitor, where we will see this tank over here. So let's look at the tank. So this is the tank. If we keep the inlet on, the tank is filled. Once the tank gets filled automatically, the flow is stopped. When we turn on the outlet valve, the tank is decreasing. Here on the screen, it shows outlet is on. And once it decreases below 2000, the inlet will get on. See here, the inlet is on. Again, when we stop the outlet on the screen, outlet is off. The inlet is full, and once it completes 3000 liters, automatically inlet will be off. Now the inlet is automatically off. We can turn on the outlet to check the water is decreasing here on the screen. Also, it is decreasing. And on the tab, once we can see a notification, the notification shows that the water level is less than 2000. So water inflow is enabled, and if the water level is full, the water inflow is disabled. In this way, we are able to control the water level. Over here, so basically in this project we have completed, in this internship we have completed a project that is based on IoT home automation, for which we have just now seen the simulation. So basically what this project does is, we are controlling from a Blink IoT app from our mobile phones, where we look that when we turn on the heater will start. It will show on the LCD screen. So heater turn off mechanism is controlled by this app. Then cooler turn on mechanism is controlled by this app, and LED blinking using LDR is controlled by this application, and temperature sensor is also controlled by the application, and the temperature is visible on the mobile screen, and water tank outflow and inflow of water is also controlled in this project, and the notification is sent to the IoT application. So basically we are able to see the notifications and the temperature changes and water level changes on the mobile phone on the application, and we are able to control it from the mobile, and we can see that on the laptop screen on this PixSim Lab simulator. So this project is made by Taslima Nasreen. Thank you.